Hey guys, welcome back to a new video. In this video, I will give you really all the information you need to know about Jetpack Compose effect handlers. I already do have a video about that in my Jetpack Compose Basics playlist, which I made very early when Compose just got stable. And that video is okay, however, I got quite some comments of people who did not really understand what I was talking about. And nowadays I also know a little bit more about these effect handlers and especially about the use cases because, I was just now using Compose for, more than half a year. And I think I can now just make a better video about it, a more detailed video where I will just go through all these effect handlers that there are. You will find jump marks to jump to these. And I will, of course, also first of all explain what that actually is and why we need these. So first of all, to understand effect handlers, we need to understand what a so-called side effect is. So side effects are, in terms of Compose at least, are something that escapes the scope of a composable function. And that sounds very complex right now, I know. So I think we better just jump into Android Studio and take a look so I can give you an example of what that is. Here you can see a very simple example of a side effect. We have a private variable I, which is simply set to 0, and we increase this here in our composable button scope. So you can see we have some state here, just text state, and when we click the button, we add a hashtag, and we display this here in our text. So what's the problem of this code? Well, the problem is that we increase I by 1 here, and that would be considered a side effect, because that is something that escapes the scope of a composable function. This I has nothing to do with Jetpack Compose. It's not a compose state or anything else we would want to do here. And the problem is, like this is of course a super simple example, but imagine this would be a network call. You would simply call a network function here. And then whenever this function here actually recomposes, you would actually re-execute your network call, and you have no influence about how often and when this function will actually recompose and re-trigger the network call in this case. In this case specifically, whenever we actually attach a hashtag here to the text state, this would mean that this block of code would recompose, and it would simply increase I by 1 whenever the text changes. However, we don't have any influence on that. It could, of course, also recompose more often. So that's something you really want to avoid, to just do non-composed things in composed code. So what can we do to actually avoid this? We can use effect handlers, because sometimes we just have to do these things that would escape the scope of a composable function. For example, if you want to collect a flow or so. But directly doing this in the composable is a terrible practice. Really never do this. However, we have these effect handlers here, which I will now go through step by step. I will explain all of them. As I said, you will find jump marks. And after this video, you will really know and understand the different effect handlers, when you should use which are rather important, which are rather rarely used. So you will have a really good understanding about these after this video. So make sure to watch it till the end, of course. The first effect handler that I want to talk about, and that's probably the most commonly used one, is called LaunchedEffect. And if you watch my videos, then you will probably already have seen me use LaunchedEffect before. Let's actually delete this stuff here and create a LaunchedEffect block. For that, we can simply say LaunchedEffect, and you can say that takes a key and a block. So let's actually remove the block here and just use a normal lambda block here like this to omit the parameter. And now, what does that actually do? What does that key mean? Why does it say key 1 and not key 2? So first of all, we get a CoroutineScope here. You can see that's a CoroutineScope. So we can execute suspending functions in here. We can say delay, and we delay this for a second, for example. This LaunchedEffect block here is essentially a composable. So if we hit Control Q, or just hover over it, you can see that's a composable. So we are safe to actually use that in a composable function, or we rather can only use that in a composable function. Now, this key is something we can pass to this LaunchedEffect block, and that could, for example, be a state in Compose. So if we now use our text state here, what that would mean is whenever this text state changes, this coroutine would be cancelled and relaunched with the new text value. So if you delay this for a second and then you print the text is text, then whenever the text actually changes, for example, when we add a hashtag like we did before, then the coroutine would be cancelled and relaunched. So it would simply cancel the delay if it's currently running and would relaunch the coroutine with the updated text. So the one that contains one more hashtag. And yeah, unless we don't change it again, it would then print this text here after a second. That's a very abstract example, and I know you will probably not get why this could be useful. So that's why I prepared two simple examples here. Example one is actually if we have a view model here. You can see LaunchedEffect view model, and very commonly we have a shared flow in view models in which you simply send events. So you can see we have screen events for whatever screen that is. For example, if you want to show a snack bar or navigate to a different screen, we can send these events from the view model to the UI. So here you can see we emit a new event, show snack bar event, and we want to show snack bar with the text hello world on our screen. So how can we now collect this flow in our composable? Because if we would just do shared flow.collect in the composable function itself, that would be a side effect, because the collect function would be called with every single recomposition, and we can't control that. So what we can do is, if we take a look here, we can simply use a LaunchedEffect block, passing true as a key. Why true? Well, if we pass true, we make sure it's actually only called once. So the first time the composable here is composing, this LaunchedEffect block is executing, and it's actually never cancelled and relaunched unless the composable here actually leaves the composition. And in here, we are now safe to actually collect the shared flow, because this is now not executed with every recomposition anymore. Instead, only the first time this composable actually enters the screen or is composed for the first time. And then we can safely collect these events here and do something with these, like show our snack bar or use our nav controller to perform the navigation. Another example that would actually use such a key here would be to launch an animation. So if we take a look here in this composable, it actually gets a counter and then creates an animatable out of that counter, which starts at the initial value 0. We sadly have to use floats here, even though it's an integer. And then we can use a LaunchedEffect block using this counter state. And whenever this counter state now changes, we will cancel this line and actually relaunch it with the new value. So if you have, for example, some different screens, that's actually something I used in my recent course about a multi-module architecture. There I actually had values, like also such a counter value, that reflected the current calorie count of a specific user. And depending on the current day the user has selected, we actually change this counter. So for example, for yesterday, it could be 1,500 calories. Then for today, it could be 1,800. And in between these days, like if we switch, we want to animate from the old value to the new value. So it just quickly counts out and we have a simple counter animation. So in that case, as soon as we call this composable function with a new counter value, it would actually cancel the old animation and launch a new one where it will animate the existing animatable with the current value to the new counter value. And as you can see, the animate2 function is a suspend function, so we have to execute it in a coroutine, which we actually get here with LaunchedEffect. So that's an excellent use case for actually using a LaunchedEffect, and I hope that's now a lot clearer when we can actually use this and for which things that makes sense. Let's get to the next effect handler, and that is rememberCoroutineScope, which I prepared something here. You can see with rememberCoroutineScope, which is also a composable function, we can get a reference to a coroutine scope that is aware of the composition here. So as soon as this this composable here is actually leaves the composition, the coroutine here in all the coroutines in the scope are actually cancelled. So if you actually, for example, click on a button here, as you can see, you can simply launch a coroutine inside of a composable function, do any kind of suspending calls, do network calls, whatever, and you're actually safe to do that. Important here is that you only use this in callbacks. And with callbacks, I mean things like onClick here. Just things that don't have anything to do with the actual composable. So you don't want to do something like this and you do your network call here, for example. It even gives us an error. Yeah, it just says that, yeah, even it should be done in LaunchedEffect or just in our callback here, like onClick. Because if you do this, then you would again have the side effect that you don't want, that you want to prevent. Because with every recomposition, you would launch a new coroutine here, which is very, very bad. So only use it in onClick, in onTextChange or whatever, just these typical callback functions, and then you're good to go. However, you actually not really need this scope here, just rarely if you need to launch an independent coroutine, maybe in a LaunchedEffect block. But usually, since you, if you have a solid architecture with a view model, then you can do all that via the view model, since it already has a view model scope. And usually you much rather want to use that. So yeah, it's not that often needed. Let's get to the next effect handler, and that is rememberUpdatedState. Here I will take the example they actually also have in the Android documentation, because I like that example and I think it makes it pretty clear. So imagine you have a splash screen, and that would be your splash screen composable. And then you have a Lambda function on timeout that gets triggered as soon as your delay for the splash screen actually finished. So you show it for 3 seconds and then you call on timeout. You of course only want to do this once. So you pass true for the key here in LaunchedEffect. What's the issue currently with this code? Well, the issue is if this composable function gets actually called with a different timeout function, then this LaunchedEffect block wouldn't actually consider the new timeout because it was launched with the old one. And since we don't pass this on timeout function for the key, because we don't want this block to be relaunched when on timeout changes, which would then extend the duration of our splash screen, because of that, it would actually not really override this on timeout function. And for that, we have something called rememberUpdatedState. So we can say val, maybe updated on timeout. And that's equal to, or that's rather, we can use the delegate way here, by rememberUpdatedState. And we pass our on timeout function here. And that will just make sure to also update this updated on timeout value here whenever on timeout changes. And it will be considered here as long as we actually use that. So updated on timeout. And by doing that, we're good to go. So this will still only be executed for 3 seconds in total. It won't be relaunched, but it will consider new values to this Lambda function in case we actually pass these. Then the next very commonly needed effect handler is DisposableEffect. Let's take a look at that. So right now, here we actually just have a typical lifecycle event observer, which is used or which can be used in a composable function to simply intercept these lifecycle events. So when your activity actually goes in the pause state, you can simply have this function that gets triggered, check, okay, is it currently in on pause? And if so, we simply print a line or do whatever you want to do. What's the issue currently with this code? There are 2 issues. On the one hand, of course, we directly declare these observers here, like this observer, directly in the composable. So it would be declared with every single recomposition, which we don't want. However, we could put this in LaunchedEffect, right? No, we can't, because this observer is an observer that needs to be cleaned up after being used. Like if the composable leaves the composition, we don't want to use this observer anymore, so we need to dispose it. How can we do this? We can't do this with LaunchedEffect. Instead, we need something called DisposableEffect. It's similar to LaunchedEffect. We can also pass a key here. In this case, we want to pass our lifecycle owner, so this DisposableEffect is just relaunched whenever the lifecycle owner changes. And then in here, we can simply put the observer. And you can see we get a big error here, because DisposableEffect has the requirement that we implement the onDispose function. So first of all, we actually want to make sure that we add this observer to our lifecycle owner actually, otherwise it's not considered. Like this, add observer, observer. And yeah, that so far so good. So this will now make sure that we get these events. However, it does not make sure to actually clean these up. For that, we actually have lifecycle owner, lifecycle remove observer. So this needs to be called when the composable leaves the composition. However, how can we do this now? Well, with DisposableEffect, we have the requirement that it's actually finished off with an on dispose block, and this will be called exactly in that case. So when the composable leaves the composition, it will make sure to actually remove this observer here before, so there is nothing leaking. So in general, whenever you have something that you need in a composable that requires some kind of cleanup, which is typically the case with callbacks, then you want to use DisposableEffect, and a very common use case of that is just to intercept lifecycle events, but there are more use cases, of course. Then the next effect handler is a very simple one, and that is SideEffect. And that is, yeah, you can see it doesn't take any parameters. It's just a lambda block here. SideEffect gets called whenever your composable is successfully recomposed. So pretty simple. The use case for that is if you have some kind of non-composed code. Let's say you have an integer here that's not composed state. Maybe you get that from an API, like a third-party library or whatever. And that's not state for whatever reason. And you actually need to treat it like a state. Maybe you need to update some other thing in your code, whatever, with this non-compose counter whenever your composable recomposes. Then you can use SideEffect and actually do this in here. So the Android team used an example in their documentation that used like a Firebase user, which is not a composed state. And whenever your composable recomposes, they just needed to make sure to update the analytics Firebase user ID or so. It's something that's really not necessary that often, but it's still worth mentioning here that this exists. And in the end, it just gets called whenever the composable is successfully recomposed, which is the most important thing here. So if you need this behavior, use SideEffect. The next one is called produceState. Let's take a look in that. That's a composable function, and it returns this produceState function here. Let's see what that does. That function gives us a CoroutineScope, just like LaunchedEffect. So in here, we can call suspend functions, as you can see here, with delay. And the purpose of this function is just to produce some kind of state that changes over time. So it's kind of similar to a flow. So if we want to construct a flow, then we can also emit multiple values over a period of time. And this is pretty similar here. So we start at a value 0, and then as long as that value is less than the value we passed here, we simply increase the value and wait for a second. So we just count up to that value every second. That's all that happens here. And every time we increase the value here, it will actually also update the state this function returns. So it's in the end pretty similar to just using a flow here. Flow of type integer. And then instead of increasing the value here, we can we can create a value here that starts at 0. We can emit the initial value. Here, increase the value. We emit the new value in every second, and then we just call .collect as state. So the initial value is 0. And then we actually also don't need to emit this here. So that would be the equivalent in form of a flow, but yeah, so that we don't need to use this collect as state function, we can also use produceState, which is the more composed way, I would say. Just that you've seen this. Quite handy in some use cases. So yeah, let's get to the next one, which is a little bit more tricky. That's called derivedStateOf, which we can't see yet here. But let's actually take a look at this code first. So we have a counter state that starts at 0. Then we have a counter text that just says the counter is whatever value you have on that counter. When we click on this button, we increase the counter and just show the updated text here. So as soon as the counter is actually increased, this text will actually be recomputed and will just update, and the text here will update as well. However, what's happening here behind the scenes is that whenever the counter is updated, this text here is really recomputed. So in this simple example, that's really not an issue. But recomputed here means, in form of the string, that this is concatenated together again. So it's pretty much the same as if we would do something like this. Maybe this makes it a little bit clearer. That every time we access this counter text, it's actually taking this string and this integer and concatenating it, which is a computation, you can say. And every time someone actually reads from this text, this is done again. However, with a derivedStateOf, we can prevent this behavior. So this concatenation here is just a placeholder for a very complex action. So if you have some kind of complex thing that depends on states that changes over time, then you want to use derivedStateOf. So let's take a look how this looks like. We can say by derivedStateOf, and then simply put this stuff in here. So let's talk about what derivedStateOf now is and how this works, what it does. When it actually, when counter text is accessed the first time, it will compute this string. So it will simply cache the string that it actually, concatenated here. So for the first call, it will be simply, the counter is 0. And that string will now be cached, so the result of that computation. Now, when the text here accesses this counter text, it will get the cached version now instead. So it won't recompute this concatenation, which is really cool and really helpful if you actually have a very complex thing here to do that depends on states. And now, if actually one of these states that you use in this block changes, like this counter, let's say we now increase this by 1, then this derivedStateOf function will recompute that string, will reconcatenate it, and it will automatically notify all these different composables that use that counter text, like in our case the text one here, and this scope actually as well. And yeah, they will actually have the new change. But as long as the counter is not increased, any composables that access this counter text will access the cached version and not, it actually won't recompute the string every single time here, which is, very simple example here. It won't be noticeable with a simple string, but if you have some kind of complex thing you want to do that requires some states to be computed, then definitely use derivedStateOf. It's an amazing function. Let's get to the very last effect handler we have here, and that is called snapshotFlow. So maybe you already know the collectAsState function, which I also quickly mentioned here in this video. If you have a flow, then you can use collectAsState to get the flow in form of a compose state. SnapshotFlow is the exact opposite. So we can actually take a compose state and construct a flow out of that emits values whenever the compose state changes. So here, for example, if we have a scaffold state, and the scaffold state contains a snack bar host state, and we actually want to have a flow for whatever reason that emits the snack bar message whenever it actually changes, then we can actually use snapshotFlow. So snack bar host state is a compose state, and we can then simply map this to the message the snack bar shows. Distinct until changed just means that we only trigger this flow, we only emit a new value if it actually changed. So if we emit the same value as it already emitted before, then it won't do anything, and then we can simply collect this. Very simple example here that, you wouldn't probably use like that in practice, but if you actually have some kind of compose state that you need as a flow, for example, to use these typical powerful flow operators, then you can simply use snapshotFlow. And if you're actually more interested in flows in general, how you can use all these powerful flow operators and even more, like if you really want to be able to use flows in your project in a reactive programming style, then you definitely want to use and learn with my Ultimate Flows playlist, which you can click on here for videos. And after that, you're definitely ready to use flows in any kind of project.